This is a story from 1939 regarding the SS Warimo vessel that was actually sailing across Atlantic, and this is one for the geeks, but a very cool one at that. While transiting the Pacific, the chief navigator realized that they were 3 miles away from not only the equator but the international dateline and the point of intersection. There's some spurious claims to whether this happened or did not happen, but it's actually a really cool thing, and it's definitely something that I would be inclined to do had I been in this place at this time. So it was claimed that while the vessel was transiting the Pacific, around about midnight on the 31st of December 1899, the vessel intersected the international dateline and the equator at exactly the same time. Therefore, placing the bow of the vessel in the southern hemisphere and the stern of the vessel in the northern hemisphere, thus one end of the ship was in winter, one end of the ship was in summer, which is kind of cool. And also, while transiting the dateline, it placed not only one side of the vessel in a separate date, but it actually coincided, because it was the 31st of December 1899, that actually one side of the vessel was in 1 day, 1 month, 1 year, and 1 century, while the other side of the vessel was in a different century, which is really cool, and like I say, it's definitely something I would do. I can actually claim to being about 26 or 27 years old, working in San Francisco at the time, and driving for 4 hours to go and see a tree. It's a beautiful tree, but yeah, anyway, geeks rule. So, thank you very much for all attending. My name is Andrew Wallace. I am from Miros. We're a Norwegian company with offices within the United Kingdom, which is where I'm based, hence the slightly Scottish accent, and I don't sound like my Norwegian colleagues. So, who are Miros and what have we been doing? Well, Miros have been in existence for over 40 years, specialising in delivering solutions to the offshore industry for wave and current monitoring. We've actually been in existence in Brazil since 1998, where we placed our first SMO 50 on board a Petrobras asset, and we now have approximately 50 to 60 SMO 50s out there being utilised by Petrobras. But we've 40 years of excellence within the markets we're operating. There are the offshore operations, which we look at as being the vessel type of market, and really trying to deliver solutions to those markets, not just about data. We also have offerings into the offshore wind, oil and gas, ports and coastal, and shipping. In terms of dedication and expertise, well, you've seen everything. You've seen the pink socks, you've seen the hype, you've seen a bit of fun on social media. We're really trying to change the way that people are looking at how and what we are as a company and how we're viewed. So, yeah, we get a bit excited about it at times. So I'll just run through a little bit of an animation of Miros and what we do.
Solutions for measuring the ocean's surface to the global maritime industry, helping mitigate
you didn't hear that, you can go to our YouTube site, it's all there. It's great. So, what do we do within the vessel operations side of things? Well, we offer something called Wave System, which is a combination of two sensors that we utilize. So there's the WaveX and the rangefinder. The WaveX is looking to the larger wave field, while the rangefinder is monitoring specifically the wave height directly at the vessel or at the asset itself. The rangefinder, just going into a bit more detail, this is a high frequency sensor, unaffected by fog, rain, water or spray, able to measure between anything from 3 meters to 95 meters. We can go into all the permutations about how the sensor can be utilized within Miros.app by setting up null zones and delivering the data and exporting the data. But the sensor doesn't require any calibration at all. Something which is sometimes lost on a little bit of our audience. Sometimes our clients are asking, well, where is the documentation? How do we calibrate the sensor? Where will it be installed? How are we going to make measurements to decide that it's actually accurate data? Well, we've already done that for you. It's a DNV certified alpha factor device. So we have, again, the certification from DNV to show where the sensor is alpha factor approved, and that's between 2 meters and 4 meters, and we can share that information with you. What is WaveX? Well, it almost does exactly the same thing, but in a slightly different manner. So we're taking the data from the X-band radar, the navigational X-band radar that's installed on board, and we're looking at the digitized sea clutter images or the backscatter from the capillary waves, and being able to make measurements from that. And that's going to provide you with not only wave height data, but it's going to provide you with directional wave data. Also surface current information. So we already are ticking the boxes for all the parameters which are required within offshore operations. So why is this important? Well, a few years ago we started to step away from the provision of MEC systems, bespoke MEC systems, into specializing in the delivery of the data and the sensors themselves. So we have developed something called Miros.app. If you have your iPhones or your smart devices right now, you can go onto your internet watch and you can type in Miros.app and you'll have access directly to our site. We then have through your Outlook credentials or your Microsoft credentials, you're then able to log in to your client-specific account and monitor any of your assets. That's something we've been talking about for 2-3 years now, telling the world about how great we are, how our sensors are, what we do, what we put out into there. Now, that's fantastic. It shows you how wonderful your hardware is, it talks about all the development you put in, but what happens in reality? What are our clients doing with the data? Where are they putting the sensors? And how does it really going to work for you? And that's really what most people are interested in. So in reality, you get a lot of data. Fantastic. What are you going to do with that data? Well, what we've got here is we have some missing images. What we have here is we have some raw data and some images, some data which has been taken and fed back into forecast information that one of our clients is utilizing. Now what they're doing with that is essentially what Miros can do at the same time. We can look at the forecast providers and we can actually tell you which forecast is most accurate, because we can compare it against real-time information. So where do we strengthen this system? What are we going to do with the data that's available, and how are we going to make the forecasts better? Well, we can, like I say, we can take the data from the sensors, we can put that into Miros.app, or we have data connector packages as well, where we're able to then feed the data into your weather forecast provider so they can use it as a data source themselves. Now, how does that benefit you? Well, improved sea state accuracies. So in terms of planning for a project, we know that there's not sitting there waiting, looking at your time and then just saying, well, we're going to go ahead with the project at the moment. There's a lot of box ticking to go on at the same time. There's a lot of double checks, there's a lot of verifications that take place. So if we're purely reliant upon weather forecasts, how accurate is a weather forecast? We need some real-time data at the same time to compare that against, and somebody has to make a decision along the way. But we can improve the decision-making process. So we improve the sea state accuracies within the forecast provided, and that facilitates greater confidence in your decision-making, and marginal forecasts can be confirmed. Within Miros.app, we actually have the forecast functionality as well, where we're taking the information from the EU data sites and able to put that and compare that against the real-time data as well. So you can do that within the live function of the Miros.app. So what are we trying to do overall? Well, we're trying to make sure that all stakeholders and all relevant stakeholders on a project have the information at hand and are able to share and use the information. So there may be project teams onshore, there may be project teams who are placed on board the asset, there may be planning processes which are taking place. We've even seen naval architects looking at data for future vessel builds as well. So the next phase that we'll be looking at is application development. One of the key industry conversations that we've been looking at is wave prediction. But what is wave prediction? Any ideas of what wave prediction could be? Yeah, we've had this conversation. We've taken part actually in tenders, and we've lost out on tenders because our view of wave prediction itself was that it was far too complicated in order to get into. We could be into metadata in terms of trying to understand which waves are important and where they're going to be. At specific points, you can see multiple wave trains pulling in all different directions. Now, how do you decide how that is going to affect a vessel or affect offshore operations? Well, let's define what wave prediction is going to be. So that's the first hurdle. So the first hurdle is to, instead of looking at statistical prediction, we look at deterministic prediction. Statistical prediction is already available by looking at the H-max and how that is, whether that is growing or depleting over the course of time. And within Miros.app, you can look at the wave field as well, or the wave spectra, and you can make some decisions based upon that. But from a deterministic perspective, we can decide which waves are important, which wave heights are important, which what time in the series we want to look at as well. And it looks a little bit more like this. Now, how are we geared up to be able to deal with this question? Well, we already have WaveX and rangefinder. So we have the WaveX solution, which is looking at the wider wave field, forecasting ahead maybe up to 3 nautical miles, providing you with live data, and then we have the ability to be able to analyze our prediction directly at the vessel with the downward-looking sensor. So a few years ago, we started showing this, and this was just some preliminary results that we were looking at for wave height or forecasting of or predicting of the waves. The differences that you see here, and one's a little bit more bumpy compared to the other, is just down to the resolution that's available from the rangefinder itself. It's a 50 Hz sensor, so it's going to provide you with much more accurate data compared to the solution from WaveX. What we now have is we've developed a function within Miros.app, and this is able to look at upper limitations that you may wish to provide alarms for, and we're also then able to take the data from the rangefinder itself and the MRU data and start to look at vessel motion. Why does this become important? Contractually speaking, in a lot of operations, there are significant wave height figures which are applied. But some clients are now starting to take the ethos of maybe the tank tests we did years ago are not accurate. Maybe we've made some adaptations to the vessels. Maybe the vessel's operating in a slightly different location or a unique location, and we need to understand the capabilities of the vessel better on projects. So REO validation we can assist with, and you can update the models regarding the capabilities of the vessels. You can tune those REOs. we've seen some of our clients who are now starting to take the data that they're gathering regarding their vessels and take that to insurance houses or classifications, and maybe start to think about, well, instead of operating up to 2 meters HS, potentially it could be 3 or 4 meters HS, depending upon what we're seeing as the results of the vessel's performance. So, again, we're talking about strengthening the system. What data do we have available? Well, we have wave and motion data here available. We're able to utilize that on various different projects. But we may also need to think about which projects are those going to be more reliable, or sorry, more related to. It may be during crew transfer on walk-to-work scenarios. It may be for safety and navigation perspectives. But the key one here is to think about is within DP operations. So within DP operations, I used to work for a company called Veripos, providing highly accurate GNSS positioning into both DP and survey requirements on board vessels. Something that I found, well, two things that I found fascinating while I was working for Veripos. I met with a company called Site down in Milan, and I'm giving them all the great story about how we've got 5 centimeter accuracy algorithms, and it's brilliant, we can be the most accurate solution out there in the world. And they said to me, so what? We don't use highly accurate solutions. We take the data and then we post-process it. So 1 meter is more than enough for us. So yeah, that was kind of an enlightening moment for me. Also at the same time, these highly accurate solutions, DP systems like Kongsberg don't like highly accurate systems. They will actually throw out, because they're too accurate, they will actually throw out a highly accurate system, or highly accurate corrections for GNSS. But the dynamic positioning industry has been in existence since the 1960s, but it's still not making full use of all available data. There's the question regarding currents, which is constantly surfaces. Now, why is that? Maybe it's because currents are not being measured accurately enough, or maybe it's because the data can't be ingressed or utilized in the correct way. We're having conversations now with DP manufacturers like Kongsberg and Wärtsilä and others, MT, to look at how we can take real-time current information, which is currently defined as everything you can't measure, and taking that into the DP capability analysis, or to be utilized within live DP at the same time. So it's again taking that errors that we already know that exist and trying to make improvements, really trying to strengthen that there. In terms of in terms of the development, where does that end up? Well, we've seen these ocean infinity vessels all over the planet, and that's the real big one that always grabs everybody's attention. You know, you can end up with simultaneous capability analysis and consequence analysis being key. It's a major point within any DP risk and within anything that goes wrong within DP. What happened? As far as the decision-making process goes, and again coming back to the point here of strengthening the system, we've spoken to a lot of our clients, and we see various different comments coming back regarding how the system, or what they do in existing practices at the moment. And it can be everything from swinging the hook over the side, or to how the crew feels. You know, how are we documenting data, and how are we showing the benefits, or sorry, how are we showing what we should be doing, or improving what we're doing offshore. But the data can be utilized for hindcast analysis or rerunning numerical models. And again, we can look at the safety side of things, how we're going to improve. So that's a little bit about what we've been talking about in the past in terms of vessel operations. Miros have also been developing cloud solutions for oil spill detection system. It's a very big topic for us in Brazil at the moment, specifically with IBAMA and Petrobras requirements that are have been brought in. We'll focus initially on the FPSO, the production side to begin with. So a little bit of what is an oil spill detection system and what do we provide into the market. So we're taking essentially wavex, operating it in a slightly different manner. We're monitoring the capillary waves for any differences or any null within the system, and we take the two X-band radars and we place them opposite ends of the vessels to provide a 360-degree view. What does that look like in reality? Well, what we have here, let's see if I can pause this for just a second. I know this is going to jump forward. And what we have here is we can see three systems actually in place. Just forward the pointer. What we have here are, there we go. So what we have here are, first of all, two oil spill detection systems, or two X-band radar systems, plus we have the vessels which have been tagged here with AIS, and we have the high resolution system on board the vessel. So when we manage to play this forward, we're able to see, first of all, the oil spill is detected. We're able to see the size and the area of the oil spill being calculated, and we're able to see the movement from the vessel as well to recover that. Pretty cool. Very important. Linked to production licenses or production approvals. We have the world's largest oil spill detection system currently deployed within Brazil on 8 assets, currently the size of Rio de Janeiro. But within Petrobras, they have a monitoring group called Salacar. My apologies. So yeah, they have this production monitoring suite where we're looking at every single installation, and that's a lot of data. So how's that being dealt with at the moment? Well, it's being dealt with by 15-minute screen captures and then reports. And that's got to be stored. And that's a lot of information. So what have Miros been doing? Well, again, first of all, what's the weakness within that particular process? The particular process is that the files could be opened, the files could be lost, somebody may have changed something. Not on purpose, but potentially I've opened files and I've done things to them and I went, oh, what did I do? So yeah, we've been working on improvements there. So we now have, we're currently at milestone 3. I'm just going to jump in here very, very quickly. This is not where any of the Petrobras assets are actually based. We've just got this on before, for demonstration purposes. But we're actually at milestone 3 in terms of release of Miros oil spill detection in the cloud. So what's the problem here? Well, this is about data and this is about security of data. So what we have developed is an alarms database where not only alarms providing notifications that need to be investigated, but we also have the media files. So we have the incidents, we have the location, we have the asset, we have the time, we have the size of the oil spill. And then finally, we have the information regarding the oil spill. Now again, this is not an oil spill because what we have here, joking aside, is we have the roof of the Asker office in Norway, and we have some snow, and we have another image here of the Asker office in Norway. Definitely not an oil spill. So again, just for demonstration purposes, we're currently at milestone 3. We will be at milestone 4 in December. We're contractually obliged to have this up and running in December, where all of the data will be stored locally within the Brazilian cloud. So again, we've got an initial problem of Where is the data being stored? How is the data being accessed? How is the data being reported? Well, this is the solution here. Yeah, it's again coming back to the idea of where do we make the improvements, how do we make the improvements, and what are we doing in terms of not competing with anything out there, but trying to make improvements constantly and trying to really make that a stronger solution for everybody who's involved. We already have plans for this to be updated on the existing systems that we have out there, and we've also received a purchase order this week for a non-Ivama requirement, which is what non-Petrobras Ivama requirement. So we're really starting to find that there's a big market for Miros in terms of this solution, and it'll be very interesting to see where it goes. One of my colleagues from Belga Marine, Alexandre, who's here at the front, has also been starting to investigate how do we take this and apply it into the oil spill recovery vessel market. So at the moment, oil spill recovery vessel requirements are very sparse, they're very small, very limited. We're trying to get a bit more specification on exactly what the solution would look like and how we could provide that. Where we would fit in with that. Well, Miros are already geared up to do this. It would not be difficult for us to take the existing requirements we have for the FPSOs and production platforms and move that into the OSRV market. But that will all come. So, in summary, thank you very much for hanging with me on this. First one of the day. What are Miros doing? Well, at the moment we have oil spill detection, cloud development that's taking place. In terms of the other development, we have wave fusion. I've not mentioned that because it's a sensor that's specific to the offshore wind market. There was a problem that we had where we're losing out in tenders because our sensor couldn't be utilized for wave and current and be suitable for being installed on board wind turbines because of the safety of life requirement. So we developed a sensor called Wave Fusion, made some alterations to it, and it's now successfully been installed on multiple wind turbines within the United Kingdom. The DNV certifications, we have DNV certificates on the alpha factor for the rangefinder currently in place. We're also looking at an improved weather monitoring device approval for wave system as well. So again, we'll be looking at the certification side of things, all our systems, something which Wave Rider boys are not, by the way. During a seminar that we were holding last week at Acidor, one of our clients at Ocean Pact actually remarked that they're really watching what Miros are doing at the moment because we are taking the raw data that we have available and then making a lot of back-end development, which solves a lot of problems for them. So we're looking at the cloud applications and how we can make that a bit more of a smoother process. Data quality improvements, of course, are something that's always ongoing. Automated monitoring, QCing the data, making sure that what is coming through is always being monitored for our end clients' use. And ISO 27001, well, yeah, we've got to look at cybersecurity. We have to start thinking about what are the issues or what are the problems that can exist within cybersecurity and how that's managed. We're currently have a process ongoing for that as well. So to sum it all up, what are Miros and how are we as an organisation functioning within this modern environment? Well, we have had for a number of years a process called DevOps, which means, exactly what the world is now used to. You have your iPhone, you see your iPhone being updated, and you don't even know about it. You know, so there are small little incremental steps which are taking place in terms of the development of the sensors. Rangefinder, we update rangefinder remotely. We update WaveX remotely. We update the cloud solutions remotely. Now, how do we do that? while we have about 4 packages each year that we push out to the sensors, of course, it's done a time of an agreed time. You're not in the middle of any operations going to lose any data. But we have actually about 12 to 15 updates that we push out 4 times per year in Scrums. So it's something that's really changing. Yeah, again, the improvement process is constantly there. So what improvements do you need? Any questions?
So I was actually looking at when you show waves a lot, but currents you didn't talk so much about, and then capability plots for the DP. If you have all this data, it should be able to make a narrower capability plot so you can actually increase your work with the DP vessels.
Absolutely. So, yeah, formerly being of Veripos, trying to work out exactly where and how we can progress and make developments into that sector of the market. If we look at our major developments that we've had have been with some of the major construction vessels. But that's a small part of the market. There are much, much larger parts of the market that require DP positioning or just to be on standby. So how do we get into that side of the market? Well, it's a little bit different. You know, there aren't the live data requirements that are constantly there or constantly monitoring of data for projects. It would just be a vessel sitting on standby. But maybe you want to build in current analysis. Why would you want to build in current analysis? Fuel efficiency, for starters. So instead of having, we're looking at sustainability on that side as well now. When you start to think about some of the vessel fleet sizes, you can be into 200, 300, 400 vessels. What are the fuel bills and what's the sustainability of those vessels and those sizes of fleets? Small improvements at every point in time. Current is a big one because it's the big unknown when it comes to DP. So yeah, the current analysis can be provided. We can provide WaveX on board, and that will provide very accurate current readings for the top 10 meters of the ocean surface. We've actually seen one of our clients in the Gulf of Mexico has decided to install WaveX on board the vessel because it's cheaper than getting an ADCP shipped out to the vessel, stuck on a pole, hanging over the side of the vessel, and then being sent back. We were cheaper than the postal costs. Crazy.
I have another on the cloud, because what you're saying is very interesting, that now it's transparency that's the key word. So by using the cloud, different stakeholders can look in. How do Miros see the future on this with now you are with the oil spill detection on the platforms, you have another area which is the OSRVs, but you also in the future could have other sources of data and see that in one place and share it with whoever is stakeholders on that.
Data's king, right? So I look back on being old enough and young enough to remember when Google was just a search engine, right? Now Google will be able to, and Facebook and these other data gathering companies are able to tell your health provider how long you've been sat in Burger King and how many times you've been there that week. And they can provide you with a more accurate medical costs for your medical insurance, right? Data is absolutely king. So while we're gathering this data, long term, we'll end up with substantial amounts of data plots. Now, how and where we go as a company, I would be taking a crystal ball for 1 second. We could end up with data within Guyana or within the northern sectors of Brazil, where there has been no met stations. We could be gathering data which has only been purely satellite data that's been gathered or refined over time. And there may be local anomalies which are not picked up. We may be able to provide more accurate readings when it comes to current analysis and what those impacts are going to be. Saipem had an asset called the Gimboa FSO, interestingly, they were looking at an asset integrity perspective of data gathering. So initially they were looking at it from, we have a MEX system on board and it's for helideck monitoring purposes. But actually they were able to take long-term analysis of what the vessel, of what the production platform was subjected to over 25 years, and then take that to classification to look at life extension at the same time. So yeah, when we're placing SMO50s or OSD systems on board, as I mentioned about OSD and WaveX, they operate in a very similar way. So actually all of these oil spill detection systems that we have out there at the moment for Petrobras and other clients as well, we could easily add in WaveX to that and start gathering wave data and current data, and it could be used for asset integrity perspectives as well. It's another data source, it's another data point, and provides more redundancy at the same time. So yeah, I think long term, we've got a bunch of data that we've never thrown away. We're using it for development purposes at the moment. Where do we end up? Well, we're a small Norwegian company, but you never know. Any other questions, folks? Okay, cool. I can get out here. Is it Caipirinha time yet? No? Obrigado. Okay.